Okay, so let's proceed with the problem number 8. So, basahin muna natin. So, we need to determine the head loss at pipe number 2. So, yung head loss mo daw dito. And the total head loss in the system if Q1 is equals to 15 liter per second. So, refer on the figure below shown. Okay, so this example of pipe connection is meron dito na parallel portion. So, as you can see here at point 2 dito sa junction na to, naghiwala yung flow rate mo into 2 and 3. So, this pipe 2 and pipe 3 is parallel with each other. Okay, so gaya nga nasabi ko, this is an example of problem ng series and parallel. So kung titignan nyo mabuti, ano ba yung mga equations na pwede natin gawin? So yung flow rate mo in Q1, so that is equals lang. So di ba ito yung Q1 mo? Ayan. Ang nangyayari kasi dito sa junction, nahati yung iyong flow rate into 2. Ayan. So this is Q1, so this is Q2, and this is Q3. And then pagdating niya dito, so nag-merge ulit sila para ma-produce yung flow rate mo doon sa 4. So pangalan na natin siya as Q4. So ibig sabihin, from this illustration, yung Q1 mo is just equals lang sa flow rate ng 2 plus the flow rate ng 3. And then itong Q1 mo is equals lang din doon sa flow rate doon sa number 4. Okay? So by the principle of parallel pipes, dumako naman tayo sa head loss. So ngayon, nag-establish tayo ng mga relationship ng mga flow rate and with respect do sa inyong head loss. So kapag parallel, di ba guys, ang head loss mo is equals lang kapag parallel. So ibig sabihin, yung head loss mo in pipe 2 is equals lang sa head loss doon sa iyong pipe 3. And to solve for the total head loss nitong buong system nito, hydraulic system, so the total head loss is equals lang do sa head loss ng pipe 1 plus, so it's either yung head loss sa pipe 2 or pipe 3. Okay? So maalin dito sa 2 or 3, okay lang yan, pareho lang yan. Kasi nga, equal lang yung dalawa. And then plus the head loss in your pipe number 4. Okay, so ito yung mga working equations na pwede natin gamitin in order for us to solve for the total head loss. So since guys, ang given dito is yung friction coefficient natin, therefore, ang gagamitin nating equation dito for the head loss is yung para kay Darcy-Weisbach, or that is equals lang sa ano nga yung formula natin when we consider the flow rate. So, di ba equals siya sa 0.0826 of your friction factor F multiply by, may nagpatak, F multiply by L times Q squared all over the diameter raised to 5. Okay, so since na-establish na tayo ng equation na yan, ano bang pwede natin gawin? Okay, so with this equation, pwede kasi nating makuha yung flow rate, yung head loss mo for pipe 1 and for pipe number 4. Okay, so computein muna natin yung head loss natin para kay pipe number 1. So HF sub 1 is equals to 0.0826 times the friction factor na 0.025 times the length of the pipe na 60, and then multiply by the flow rate, so that is 15 liter per second. So i-convert natin siya to cubic meter per second, or just simply divided by 1,000, or that is 0.015 squared all over d raised to 5, or 150 mm, so that is equivalent to 0.15 meter raised to 5. Ayan. And kunin na rin muna natin yung head loss natin para kay pipe number 4. So that is 0.0826 times 0.025 times 100, and then multiply by tama, ito pa. Nalito ako. 0.015 squared, and then yung diameter niya is 0.1 raised to 5. Ayan. So pindutin muna natin yung dalawang head loss na yun. 0.0826 times 0.025 times 60 times 0.015 squared divided by 0.15 raised to 5. So para sa HF1, so that is 0.3671 meter. So, itago ko muna siya sa value ng A. Store A. And yung isa, ano bang papalitan lang natin dito? So, yung 60, palitan natin ng 100. Na-edit ko lang yung input sa ALQ. And then, yung 0.15 magiging 0.1 lang. So, ang answer sa kanya is medyo malaki Tama naman yung input natin. Okay, so ang nakuha ko is 4.6463 meter. So, itago ko siya sa value na B. Okay, so what is the next thing that we need to do? So, siguro apply na natin yung equation na to. Itong Q1. Where Q1 mo is equivalent dito sa flow rate na to. 0.015 cubic meter per second is equals to Q2 plus Q3. Kaso ang problema, wala pa tayo ng Q2 or Q3. So, i-retain muna natin tong equation na to. So, let this be our equation number 1. And ang goal kasi natin is ma-minimize or magawa natin na iisa lang yung ano. So, sunod kong gagamiting equation is itong pangalawa. Ito. So, ang gagawin natin in terms of head loss, kukunin natin yung relationship ng Q2 in terms of Q3 para maging isa lang yung unknown. And then kapag nakahanap tayo ng relationship ng dalawa, i-substitute natin siya dito. Okay, so by applying the equation, ito, yun yung ating head loss formula. So that is 0.0826. So ito yun So HF2 is equals to HF3. So let this be our equation number 2. So 0.0826 para sa pipe number 2. So F na 0.025 multiply by the length of the pipe na 150 and then times the flow rate. So ito nga yung hinahanap. This is unknown. U2 squared all over diameter. So that is 75 mm or 0.075 raised to 5. So equals lang siya sa 0.0826 times the friction factor. So pareho lang, 0.025. And then the length of the pipe na 120 and then multiply by Q sub 3. So squared all over the diameter of the pipe na 0.05 raised to 5. So, i-cancel mo na lang yung mga common na terms. So, pwede natin i-cancel itong 0.0826. At the same time, yung friction factor niya na 0.025. Kasi maa-cancel lang din naman talaga siya. Okay, so, ang gawin natin, pindutin natin sa ALQ. So, i-squared ko muna to. And then, mamaya natin i-cancel yung squared niya. Okay? So, etong 120, multiply mo lang nito, 0.075. And then, divided by 0.05 raised to 5, divided by 150. So, gagawa tayo ng answer in terms of Q sub 3. So, 120 times 0.075 raised to 5 divided by 0.05 raised to 5 and then divided by 150. Yan cross multiply ko lang. So, that is 6.075 ng Q3 raised to 2. And then, nagawin natin, i-raise natin ang 1/2 or square root nun para ma-cancel yung squared. So, ang answer dito, so square root lang ng 6.075. So, that is 2.4648 ng Q sub 3. So, maa-answer na lang din yung square. And so, I will let this equation as 2a. So, now, by solving 1 and 2a simultaneously, so by solving 1 and 2a, mapapalabas natin yung value ng Q3. Okay? So, substitute lang natin dito. Or that is 0.015 is equals. So, yung Q2, ang gagamitin natin value is ito para isa na lang yung unknown. So, 2.4648 of Q sub 3 plus Q sub 3. So, we will have an answer for Q sub 3. Or that is simply 0.015 divided by 1 plus 2.4648 or 3.4648. So the answer here is 4.3293 times 10 to the negative 3 Q cubic meter per second. And to solve for Q2, so that is simply equals lang. So just take the difference. Ano? So 0.015 minus Q3. So mapapalabas natin yung Q2. So by using equation number 1. Okay? So 0.015 minus the answer. So that will be 0.01067 cubic meter per second. Okay, so since guys meron na tayong value ng flow rate at Q3 and Q2, I think we can now solve for the value of the head loss at 2 and 3. Okay? So unahin muna natin yung head loss para kay 0.2. So to solve for that, so just use the same formula. 0.0826 multiplied by the friction factor for pipe number 2, 0.025. And then multiply by the length of the pipe, 150. Times yung flow rate niya. So ang gagamitin natin is ito. So 0.01067 raised to 2 over the diameter of the pipe na 75 or 0.075 raised to 5. So meron na tayong value ng head loss para kay 0.2. So pindutin muna natin 0.0826 times 0.025 times 150 times, hindi pala ako nakapag-store, no? 0.01067 squared divided by 0.075 raised to 5. Okay, so the answer here is 14.8605 meter. Okay, medyo malaking head loss. And, ano ba, pinapahanap to, di ba? Ayan, so may sagot na tayo doon sa isa. And para ay pipe number 3, so that is simply equals lang sa ganun din. So 0.0826 multiplied by 0.025. So I think pare-pareho naman yung friction factor niya. And then multiply by the length of the pipe na 120 times yung flow rate kay pipe number 3. So ito, that is 4.3293 times 10 to the negative 3. Ay, nangyari. Sorry, lumipat. Ala, nawala ako. Squared over the diameter. Teka lang ha. Tapos ko lang kauntit na wala sa... Ayan. So, 3. Be careful. So, 50. So, that is 0. That is... wait lang ha. Kagulo-gulo na. So, divided by 0.05 raised to 5. Okay. So, we will have the value for head loss 3. So, 0.0826 times 0.025 times 120 times 4.3293 times 10 to the negative 3 squared divided by 0.05 raised to 5. So, ang answer doon is parang pareho lang sila. Paano napindot nyo? Okay. So, na-prove na natin na pareho lang yung ano nila. So, 14.86. Meron lang konting putal dito, pero okay lang yan. Almost equal naman siya. Yan, nagtataka ako. Kasi nga, yung head loss mo kay pipe number 2 and head loss mo kay pipe number 3 is equal. So, ito naman, almost the same sila. So, because of rounding off, nagkaroon lang ng konting difference. Pero okay lang yan. Ano? So, ba't ko pa nga inompute ng head loss 3? So, meron na nga pala ako nito. Anyway, at least na-prove natin. So, to solve for the total head loss, HF total, so that is simply equals lang sa head loss ng pipe number 1, pipe number 2, pipe number 3, and pipe number 4. So, maali na lang dito, sa 2 or 3. So, ano nga yung head loss natin kay 0.1? So, that is 0.3671. Isulat na lang natin yung value. Plus, ito na lang yung gamitin natin. 14.8605. And then, plus the head loss in point number 4. So, 4.6463. Okay? So, the total head loss is equivalent lang sa 0.3671 plus 14.8605 plus 4.6463. So the total head loss in the system is 19.8739 meter. Okay, so na-compute na natin lahat. Ganun lang kasimple. So, mangyayari lang dito, yan, analysis. Pagalingan mag-analyze ng problem. Okay, so next problem natin is yung tinatawag na 2 or 3 reservoir. So, walang kaso kasi kapag 2 reservoir. Pero ang mahirap dito is kapag nangyari na 3 reservoir problem na siya. So anyway, do sa next video, magbibigay ako ng example para mas maunawaan yung sinasabi ko. And may i-share ako sa inyong video regarding sa explanation ng 3 reservoir na problem for a flow in closed conduit or pipes. Thank you, and let's see you on our next video.